Hey everyone! In my previous video, I showed you a log analysis tool I built that uses pattern matching to find errors in log files and suggest solutions. Today, I'm going to share how I've enhanced this tool with AI capabilities using locally hosted language models. This tool is still a work in progress, but the journey of integrating AI has been interesting, and I've learned a lot along the way. By the end of this video, you'll understand how I've added AI to improve the tool, how local LLMs work, and some of the challenges and solutions I encountered. When I decided to enhance the log analysis tool with AI capabilities, I initially explored Hugging Face's small agent code because I watched a video by Deep Learning AI on using Hugging Face's small agent package to run agents that actually write code for you. Small agent is a specialized AI agent for code writing. The agent had promising capabilities, but I quickly ran into token limitations on the free tier. Since I'm still learning and experimenting, I wasn't ready to commit to a paid subscription. That's when I started playing with Ollama, a tool for running AI models locally on my own computer. I have a MacBook Air M3 with 24 gig of RAM and about 100 gig of available hard drive space, and it was fine running the local LLMs. This approach gave me complete freedom to experiment without worrying about costs or usage limits. I could run as many iterations as I needed to get things working correctly, which is invaluable when you're learning a new tech. The ability to experiment freely turned out to be exactly what I needed. I was able to try different models, test various prompt structures, and gradually refine my approach until I got the results I wanted. This experimentation has been an incredible learning experience for me. So, what exactly is Ollama? In simple terms, Ollama is a platform designed to make running large language models on your own computer as easy as possible. Unlike cloud-based AI services where the models run on someone else's services, think ChatGPT, Claude, Ollama, it lets you download and run these models locally. These are open source models, obviously, but what are LLMs? So it's just going back to the basics. What does a model mean in this context? A large language model is an AI system trained on massive amounts of text, and they're able to find patterns, and once it's trained on these patterns, it's able to make predictions based on the most probable next word. It's called the model because it's a mathematical representation of language patterns that the AI has learned during training. In my experiments, I tested two different models, the Llama 3.2 3B, developed by Meta, and DeepSeek R1 7B, developed by DeepSeek. You might notice that the models have a B parameter in their name, like 3B or 7B. This refers to billions of parameters in the model. Parameters are the numerical values inside a neural network that have been optimized during training to help the model predict text patterns correctly. The more parameters, the more capacity the model has to store information about the language. When the model sees the beginning of a sentence, for example, these weights determine what words are most likely to come next based on all the text it was trained on. Generally, more parameters mean a more capable model, but also one that requires more computational resources. Despite DeepSeek R1 having more parameters, I found that Llama 3.2 actually worked fine for my specific use case of enhancing log analysis. This shows that bigger isn't always better when it comes to AI models. The right model depends on your specific needs, the quality of the training data maybe, and how the model was optimized. In the future, I might revisit Hugging Faces tools for more specialized capabilities. But for now, the locally hosted models gives me what I needed without any usage constraints. Let me show you how the enhanced tool works. Just like in the previous version, you can specify a directory. You can specify a directory of log files and a search term like error, and the system finds all the log files, searches for the term, and parses the logs. But now with AI enhancement enabled, the tool does something more. After the basic pattern analysis, it sends the identified problems and initial solutions to the local LLM along with examples of the actual log entries. With this drop down, in the back end, it actually searches for all the available models that you've downloaded. In my case, I've loaded these two models, Llama and DeepSeek, and it lets me select which one I want to use. At the moment, it's running the analysis. So what happens here is the local LLM model analyzes the context. It analyzes more deeply than simple pattern matching. It identifies potential root causes, even when they're not explicitly mentioned, provides more detailed and relevant solutions, hopefully, explains its reasoning in natural language. So for this first solution on connection issues, the pre-AI enhanced solution was just telling you the basic troubleshooting measures is to check network connectivity and verifying the service status. It tells us now that with the AI enhanced solution, it gives us a more comprehensive step-by-step approach with detailed steps on what you can do. I'll just quickly scroll through them, but you can see it's quite detailed and even gives us an example code on how you can implement this in Python, where you can filter the logs. You can see there's a lot of information now that it's given to us. I'm just not sure whether they're all going to be relevant. That's something that I would like to further fine-tune with the proper prompting. But for now, I just wanted to get the code working, to make the codes of my remote Ollama server working, and share with you the status of where I'm at. Now let's dive into parts of the code that make this AI enhancement possible. I'll focus on the main differences between the original pattern matching version and this AI enhanced version. The original log analysis tool, it used simple pattern matching with regular expressions to identify problems and suggest solutions. The AI enhanced version, it builds on this foundation but adds a layer of AI analysis. The most significant addition is this agent helper Python file, which contains everything needed to connect with Ollama. And if we quickly look at the components, there's this definition of an Ollama client class which handles the communication with Ollama, configuring parameters like temperature and token limits for optimal results. I used 0.3 for the temperature to make AI's output more focused and predictable. With this setting, the model is more likely to select the most probable next token based on what it has been trained with. This is suitable for tasks requiring factual accuracy and consistency. And there are several other functions here. Checking whether Ollama is available. That's when I started playing with a remote Ollama server on my other computer. And this is where it's pulling the available Ollama models and displayed into the user interface. This function is when I was using the Hugging Face API, which I just kept there so that I can refer back to it later on. The prompt for the AI is defined here in the Enhance Solution Direct function. This prompt asks the AI to enhance the log analysis solution by giving it the problem, the solution, and some examples of the logs. Then it asks for it to provide a detailed explanation and specific steps to resolve the issue. Then in the Analyze Logs Python file, I've imported that agent helper enhance solutions function, which is integrated here to send the results as an enhanced solution if it finds that AI enhancement is enabled. Integrating AI into the tool wasn't without challenges. One major hurdle was getting the tool to talk to a remote Ollama server within my network, because yes, that introduced some complexity, but I was curious on using another machine with more RAM but wanted to continue developing on my MacBook. Anyway, I got over that issue, and it actually made the journey all the more interesting and deepened my knowledge of Ollama. Another challenge was dealing with the non-deterministic nature of AI responses. Unlike traditional code where the same input always produces the same output, LLMs can provide different outputs. As I mentioned, this tooling is still evolving. I see this as an ongoing learning journey where the tool grows alongside my understanding of AI capabilities. Each iteration teaches me something new about both log analysis and AI integration. The code for this project is available on GitHub. Feel free to check it out and try with your own log files and let me know how it works for you. Thanks for watching, and I'll see you in the next video.